Sorry about the break in the video. So for this box, we're multiplying -4 by x, which will give us -4x. Of course, my pen stops working now. There we go. Here is going to be -4 times 2x squared, which is -8x squared. And here we have -4 times -4, which is positive 16. We write out all four of our terms, 3x to the third, -8x squared, minus 4x, and plus 16. We then combine our like terms, but wait, there aren't any. So our final answer will just be 3x to the third, minus 8x squared, minus 4x, plus 16. That is also in standard form, so we're good to go. Try and move a little faster. The next one, we are given this polynomial. It says it represents the height in feet of an object. V0 is the initial velocity, S sub 0 is the initial height, and t is time. Write a polynomial that represents the height of an object that has initial velocity. Well, that just told me that's v0. That's 25. Initial height, it said that that was s sub 0. So s sub 0 equals 4. Then find the height of the object after 1 second. What I'm thinking is, hey, I now know this polynomial tells me some information. It's telling me the height of the object. I just need to know the initial velocity and the initial height, which I do know. Then I just need to find after 1 second. Let's start by plugging in. -16t squared plus, instead of v0, I'm writing 25 times t plus my initial height, which is 4. Awesome, I have my polynomial, now I'm plugged in, I have t left over. It told me 1 second, so t equals 1 second. Substituting in, my answer there is 13 feet when I simplify. I got feet because it told me in the problem in feet. This problem we're actually going to skip because it doesn't actually ask a question, but I was looking for you to subtract these two polynomials. On the back side, here we go, home stretch. This one is pretty challenging. It says write a polynomial that represents the area of the shaded region. The shaded region is clearly the darkened region. But I know the length and width of this and the length and width of this. Think to yourself, what could I do to find just the shaded part? Hopefully you said I could do the whole area minus the white area. So that's exactly what I'm going to do. The area of the whole minus the area of the white. I know to find the area as length times width. So I'm going to use 3x plus 1 times 5, subtracted x plus 8 times 2x minus 3. Writing this out is 3x plus 1 times 5x minus x plus 8 times 2x minus 3. You're going to need to use your Punnett square for both of these, or your box or array model to solve this. On the next one, the area of a triangle. First off, area of a triangle is 1/2 base times height. So I'm going to plug in 1/2 base, p plus 1, height 2p minus 6. Using our array here, p plus 1, 2p minus 6, 2p squared, -6p plus 2p minus 6. These are like terms. So I have -6p plus 2p minus 6, 2p squared. All of this is times 1/2. I'm not finishing these as you can see, but I'm trying to give you a start just so we can move a little faster. Simplifying the expression here, 2x to the 5th times 5x to the -7th. This one we struggle with because it's exponent rules. The first thing I'm going to do is move this negative exponent down. When I move that down, it's going to be 2x to the 5th times 5 over x to the 7th. Remember here that these are actually multiplied, so we can do the multiplication sign there. By doing that, we know that with the commutative property, we can actually move these terms around and have 2 times 5, which is 10, x to the 5th over x to the 7th. If you forgot the property for when we're dividing the same base, you can actually write this out. We have 10 times, how many x's are there? 1, 2, 3, 4, 5, over how many x's? 1, 2, 3, 4, 5, 6, 7. Then we know we can simplify. Anything divided by itself is 1, so x divided by x is 1. x divided by x is 1, x divided by x is 1, x divided by x is 1, x divided by x is 1. We are left with 10 over x squared, or 10x to the negative 2, but we never want that. When I look for my answer, it's right here as J. This is a great problem because it takes the idea of the array and puts it in a new way. So it says Rawl is dividing the trinomial 30n squared minus 3n minus 27 divided by 3n minus 3 using an array. What value should go in the shaded section to complete this step? So we've already got the 30n squared, 3n minus 3. He knew that 10n times 3n is 30n squared, 10n times negative 3 is negative 30n. We're trying to figure out what this box is. What do we know about this box and this box? We know they're like terms. If they're like terms, they need to add up to this middle term, which is negative 3. So we know this negative 30n, and whatever this term is, must add up to negative 3n. We were doing this in class, mostly in 7th and 8th period. We are using this number line, vertical number line. We're starting at negative 30, and we need to get to negative 3. Here's negative 30, let's say here's 0, here's negative 3. How much do we need to add or subtract to go from negative 30 to negative 3? We're going up, so we're thinking about adding, and from 30 to 3 is 27. So we must know that this box is plus 27n. 2 more, we're almost there, y'all. The volume of the rectangular prism, ooh, good, volume problem, is given by the formula volume equals length times width times height. Find the missing dimension of the volume if the volume is this. Great. So we have one side length, maybe a length, a width, and this, so we need to find a height. I'm going to start by plugging in. Volume is 9x squared minus 3x minus 6. Length is x minus 1. Width is 3. And then height. And that's what I want. These are all multiplied. There's something I can simplify first, though. I can simplify the 3 and the x minus 1. This becomes 3x minus 3. Little distributive property action. Still times h equals our volume. If I want h by itself, what am I going to do? I'm going to use inverse operations. The inverse of multiplication is division. So I'm going to divide. This will go to 1, so it goes away. And then I have a nice division problem. I am going to walk through this because this is the only division board problem we've seen. So I'm sorry, guys, this shouldn't be filled in. My phone keeps running out of space, so it's messing me up. But anyway, we should have 3x here minus 3. That's what we're dividing by. And we put our first term in our first box. We're then thinking what number times 3x, or term times 3x, will give us 9x squared. 3 times 3 is 9, and x times x is x squared. We do this, now we move forward like in multiplication. This will be 3x times negative 3, which is negative 9x. This is the tricky step. We know these are like terms, and we know it needs to equal our middle term, which is negative 3. So we have negative 9x plus some term equals negative 3x. If you need to draw a vertical number line, that works. We're starting at negative 9, we're going to negative 3. What's we're changing by? Plus 6. So that's positive 6x. So in this box, we put plus 6x. Negative 9x plus 6x equals negative 3x. Good. Now we know 3x times something is 6x. It's positive 2. Finally, negative 3 times 2 is negative 6. The one last tricky thing is our remainder. We know we want it to be negative 6, and we have negative 6. Since they're the exact same, we actually have a remainder of 0. So our final answer is just going to be this binomial, 3x plus 2. That is our answer, which is F. Okay, I'm not going to do the last problem. If you do this and gets correct, though, I will give you extra credit. It's really good and challenging, and we'll prepare you for tomorrow. So get a good night's sleep, eat a good breakfast, and be ready for your test tomorrow. Thanks. Bye.